and measurement scale in research methodology, or we need to know about the scaling technique when we are learning about research methodology? And the answer is very simple, that whenever we are measuring anything, then a scale has to be there. And why are we measuring? Because if you want to control anything, if you want to do some manipulation or exercise on anything, so the first and the foremost thing that is required is the measurement. For example, if you want to change the attitude of the people towards a particular thing, then you can change that attitude provided you can measure it. Suppose if you want to increase, or like you want to increase the awareness of the awareness level of the people towards a particular thing, say digital payment, or say equity shares, or awareness about particular medicine, then first thing is that you want to know what is the current level of their awareness. So to measure awareness, or to measure attitude, or to measure perception, or to measure anything, the first thing that is required is that we need to measure scale. And scale has to be appropriate, adequate. Suppose if we want to measure height of a person, then the height can be measured only in terms of meter and centimeter. And if you want to measure the weight of a person, then the weight can be measured in terms of kilogram. Time can be measured in terms of seconds and minutes and hours. So this time or weight or length measurement scales are available. But the problem is when we want to measure something other than these available scales or available units, like we want to measure attitude. So attitude, we cannot measure that, okay, so and so is 5 kg positive or 10 meter negative, positive attitude or negative attitude 5 kg. So we need to develop some measurement scales to measure attitude, or to measure the perception of the people, or risk perception of the people, or reliability coefficient of the people. These are the terms that we need that we are using very frequently, and for that we need to measure, we need to develop some scale. Scale is required if you want to measure the length. So scale is the meter. So that's why scale is required. So measurement means assigning numbers, because whenever we are measuring something, so ultimately we are assigning some numbers or other symbols to symbols to characteristics of objects according to certain pre-specified rules, like one-to-one correspondence between the numbers and the characteristics being measured. The rules for assigning numbers should be standardized and applied uniformly. The rule must not change over object or time. So like we are actually, when we are measuring some things, actually we are assigning some numbers. And how these numbers will be assigned? So there has to be some rule, and this rule should be uniformly followed. Like the number which is actually given to me, the same criteria should be allotted while assigning number to the other members of the team. Okay, it should not be different for me and different for the others. We shall discuss it in the later slides in detail, how actually this is happening. So measurement and scaling is important. Then there are different levels of measurement. One is the nominal, then ordinal, then interval, and then ratio. These are the 4 levels of measurement normally we are using, and these are the 4 scales we are actually using while developing any kind of scale in our research methodology. Now let us discuss one by one. But before discussing this scale, let us have some idea about what actually is called variable. So the variable is that anything which is capable of assuming any value, that is called variable. Okay. So because it keeps on varying, so it can assume any value. For example, gender is a variable, and what will be the variations? It may be male or female or third gender. Age is a variable, and what are the variations? Age from 0 to any n number of years, it can assume any value. Height is a variable. So from 1 centimeter to any number, that can be the height. Education is a variable, that if you want to measure someone's education, so somebody might be illiterate or literate or class 5 pass, 6 pass, higher secondary pass, matriculate, graduation, postgraduate, PhD and other professional qualifications. These are the variables for education. So the variable which is actually measured, the outcome of variable is which actually is measured is called attribute. So variables are measured in terms of attribute. So every variable have certain attributes. For example, gender is a variable, and what are the attributes? It may be male or female, or maybe the third gender for that matter. So gender is a variable and it has different attributes like male or female. Age is a variable and any number of years will be the attributes. Okay, education or anything, whatever we are discussing, or as per your topic of your research, you may have different variables, and accordingly you may have the different attributes of all those variables. So there are certain qualities of variables. First thing is that it has to be exhaustive. It should include all possible answerable response. Like if you are asking a variable like gender, and we are giving only two possible responses at male and female, and someone is suppose third gender, then what response that person will be giving, he or she? So it is not a good variable. So the variable should have, it should include all the possible answerable responses. Suppose someone's marital status. So normally, what are the different attributes of a marital status? Someone may be married or someone may be unmarried. But do you think that these are the only attributes of a marital status? Marital status is a variable, and someone may be married, unmarried, someone may be widow, someone may be widower or divorcee or separated. These are the different attributes. Okay, so this has to be exhaustive. Then mutually exclusive. No respondent should be able to have two attributes simultaneously. For example, employed versus unemployed. If someone is employed, definitely he or she will be unemployed. If someone is a male, definitely that person will be female, will not be female. If someone is illiterate, it means that that person is not literate. Okay. Then what is the level of measurement? The relationship of the values that are assigned to the attributes for a variable. So actually we are measuring the relationship of the values that are actually assigned to the attributes for a variable. Different attributes of a variable, any attribute. So we are actually measuring that attributes only. So when we are asked, we are actually talking about the term like measurement variables, measurement levels, or measuring different measurement scales. So actually we are not measuring variables, rather we are measuring the attributes for a variable. That should be very much clear. Okay, now how? Okay, the values. So the relationship of the values that are assigned to the attributes for a variable, like suppose party affiliation. Which party affiliation do I have? This is one variable. And like this is one American example, like someone may be a Republican, someone may be Democrat, or someone may be independent. So party affiliation, this is a variable. Attribute, someone may be Republican, independent, or Democrat, and the values we are assigning, that is 1, 2 and 3. Suppose if someone is Republican, we are giving 1, independent 2 and Democrat 3. But it does not mean that Democrat is 3 times better than Republican, or Democrat is 3 times having more probability of winning, or 3 times more number of seats. Nothing. These are just numbers. And what these numbers signify, we will just come to that later on. So this level of measurement is important. Why? Because this helps you decide what statistical analysis is appropriate on the values that were assigned. So what kind of a statistical analysis will be appropriate? It depends upon what kind of scaling technique you have used. For example, those who are familiar with the statistics will be knowing that if you want to use a regression analysis, then the variables has to be either in the ratio scale or interval scale. Or if it is an ordinal variable, if the variables are in the ordinal scale, then we can use ordinal logistic regression. So what kind of statistical analysis will be used? It depends upon what kind of scale we have used for measuring those variables. If it is in ordinal scale, then we have to use ordinal logistic regression. If it is in ratio scale or interval scale, then we can go for the multiple linear regression. But if it is in binomial scale, then we can go for the binomial logistic regression. If it is in nominal scale, then at the most we can go for the chi-square test, or simply mean and standard deviation. There is some descriptive statistics we can use for nominal. So that's why what kind of a statistical analysis we will be using, it depends to a large extent that what is actually our measurement scale. And it also helps you to decide how to interpret the data from that variable. How the data will be interpreted from that particular variable, it will be decided based on what kind of a scaling technique we have used. Okay, we'll come to that in the next slides. So the first thing is that nominal measurement. It is the most crude form of measurement. The very beginning, the least refined form of measurement is the nominal measurement. The values name the attributes uniquely. Simply, the values actually they name the attributes and nothing else. For example, in cricket, the jersey number, suppose the jersey number 10 belongs to Sachin Tendulkar. So jersey number 10 belongs to Sachin Tendulkar. It does not mean that Tendulkar is 10 times better than other players, or the number 1 jersey number 1 is whosoever jersey number 1 will be there, he or she is the best player or the first player or nothing. This is just a number. Okay. In your class, the roll number of a student. So the roll number of the student and the name of the student is just the name. Roll number 1, it does not mean that the boy is a first boy. In some of the schools, it may be the practice, but normally the roll numbers are just a number assigned to identify a student. So the roll number is a variable, but this is just a name given to the attributes uniquely. That will be unique to that person. Roll number 1 will be 1 only. That will be unique, and no one else will be the roll number 1. And that roll number 1 will be given just to identify that student who is roll number 1. So and so on is the roll number 1, or so and so one is having the jersey number 1, or so and so is having the Aadhaar ID number this much. That is just a name or the identification mark given to that particular person. So, or like PAN number or account number or anything, these are the data, but they are the nominal data. They are just given to identify the person or identify that attribute and nothing else. So that is the first form of measurement, is nominal measurement. And the name does not imply any ordering of the case. As I told you that roll number 1, it does not mean that roll number 1 is better than roll number 2, or roll number 2 is like inferior to roll number 1, or roll number 3 is inferior to roll number 1 and 2. Or like say whosoever's account number is say 001, it does not mean that the 001 account number is, bank account number is having more money than the account which is having the number 002. It is just a number. Remember, this is just a number, just to identify that attribute and nothing else. And the value does not imply any ordering of the case. For example, jersey number in football, we have already discussed jersey numbers in football or cricket or any game. That jersey number is just a number given to identify a player and nothing more than that. And even though the player 32 has higher number than the player 19, you can't say that from the data that he is greater than or more than the other. Okay, like MS Dhoni's jersey number is 7, Sachin Tendulkar's jersey number is 10, and say Saurabh Ganguly's jersey number was 1. It does not mean that Saurabh Ganguly was the best player better than Sachin Tendulkar, 10 times better than Sachin Tendulkar, or Dhoni was 7 times better than Sachin Tendulkar, or Dhoni is 7 times better than nothing ordering of this sort. It is just a number. Remember, I'm repeating time and again that this is just a number given to identify that particular attribute and nothing else. So, for example, gender. So, someone will be male or female. So, for male, suppose we are putting the number 1, and for the female we are giving a number 2. So, 1 and 2. So, for a specific, against a specific respondent, we are putting a tick mark that male, or suppose if someone is female. So, male or female is just a just an identification that so and so is male. It does not mean that so and so is better than someone else, better than the female, or females are better than the males. For the males, while doing this classification or entering the data in Excel sheet or MS, SPSS or any other software, we can assign any number, like the males can be given 1, or the females can be given 0, or the males can be given 1, females can be given 2, or vice versa. But it does not mean that this 1 is better than 2 or 2 is better than 1. It is just a number given to identify that so and so is male or female and nothing else. Another example, marital status. Someone is married or single or divorced. So this is just a number, just to identify whether the person is married or unmarried or divorced or single or any other marital status. So suppose we have given a number that married will be given a number 1, single will be given a number 2, and divorce will be number 3. It does not have any ordering. 3 means only divorce, and this is just a number used to signify whether divorcee is number 3. 3 actually stands for divorcee, or 1 stands for divorcee, or any other number. Suppose this question, with whom are you traveling on this flight? Suppose this is a question. The question here, you are designing some question here, and this question is given to some person, like, with whom are you traveling on this flight? So the answer is no one, or spouse and children only, business associate, any organized tour group. This answer can be anything. So if suppose someone have given a tick mark, I'm not traveling with anyone. Okay, so I might be giving a tick mark here. Someone will be giving a tick mark that children only. Someone might be going for a business trip. Someone will be going with their spouse. Someone will be going with their family, spouse and children. So different combinations are there. So it does not have any order that this is better than the previous one, or the previous one is better than the current one. Nothing like that. It is just an order, just identification that with whom are you traveling. So this is also an example of nominal scale. Next level of measurement is the ordinal measurement. As the name itself is indicating that it's ordinal, it has some order. So when the attributes can be ranked, it can be ordered. Okay, like the position of the students in a class, like someone who has got the highest mark will be given the first rank, the second highest mark will be second, and third and fourth and fifth. So the position first, second, third and fourth, this actually is in one order. So this is an ordinal measurement. Or suppose someone is coming first in a game, so the person who who has covered a distance quickly, in the quickest manner, he or she will be given the first rank, then the second and third and fourth and fifth and so on. So that is actually an ordinal measurement. So here the number 1 will be given to a person who will be the first in that particular game or assessment, or in a particular criteria, that particular attribute. So the number 1 is given to the person who is best, number 2 is given to the person who is next to him, and number 3 is given to the person who is next to him or her. So here this 1, 2 and 3 have some meaning. Like 1 is definitely he is better than the others. 2 is he is better than everyone other than number 1. Number 3 is better than entire group members other than number 1 and 2. So this is actually an ordinal measurement. So distance between the attributes do not have any meaning. Okay, but here the problem is, or we have to take into account that suppose a student have got 95 and this is the highest marks. So definitely we have given him number 1 position. And the second student who have got 94, so that student will be given second position. And suppose the third position is given to a student who have scored 80. So the first and second, the difference is only 1 mark, but between the second and third, the gap is, the distance is of 14 marks. So the rank between the attributes do not have any meaning. Okay, but it will be first, second and third. For example, educational attainment as 0, less than higher secondary 1, some higher secondary 2, higher secondary degree, some college degree, post college or post graduation. So this is the educational attainment. So suppose someone have less than high school, we have given him 0. Then high school 1, high school degree 2. Then that person has went to college, we have given him 3, college degree 4, and post graduation 5. So 0, 1, 2, 3, 4, 5. This actually is an order. Okay, so this is an ordinal data. The person who have been given 1 is actually less educated than the person who is given 2. Okay, so here the distance from 0 to 1 the same as the 3 to 4, though it is, but actually the meaning is different. Like the person who is in postgraduate and the 4 is just a degree college. So the distance actually there is, though the distance is same, but it has a lot many meaning between this 0 and 1. 0 and 1 is also just the distance is 1 only, but here actually it's a comparison between the less than high school and high school. Anyway, some examples of ordinal data, like airline food service to me is extremely important, very important, somewhat important, not very important, and nor or not at all important. So here suppose you are doing a survey and the question is like airline food service to me is important to not important. So here suppose someone have put a tick mark here, that is extremely important, and someone have given a tick mark here. So this data is actually in order. So suppose someone have given a tick mark here, extremely important. For him the airline food service will be extremely important than the second one, someone who has given a tick mark here, very important. Okay, so for him it is more important than this person. And suppose this person has given a tick mark here, somewhat important. So for this person will be, this is lesser than this previous two responses. So this is actually, we are seeing an order in this response. Then what age group are you in? So someone might be in this age group, someone might be in this age group, on this or this and this. So here is an order. Suppose someone have given a tick mark here, definitely he or she will be younger in age than the person who have given a tick mark here or here or here or here. Okay, so accordingly we are seeing an order. Okay. So suppose someone have given a tick mark here, that person actually is the 45 and above, that person is actually oldest in this particular age group. So how often do you consume soft drinks in a typical week? Here less than once in a week, 1 to 3 times per week, 4 to 6 times per week, 7 or more times per week. Here also it is an order. Okay, so just see, this ordinal data or the ordinal scale can be converted anything. Now here okay, we'll discuss it later on. So this is actually about ordinal data. Next is the interval measurement, when distance between the attributes have meaning. In case of ordinal data, the distance between the attributes, it does not have any meaning. But here in interval data, the distance between the attributes have some meaning. Okay. For example, roll number of a student, it is a nominal data. But the marks of a student, it is an interval data. It is an interval scale. Suppose someone have got 95 marks, someone have got 90, someone have got 86, someone have got 75. This is actually an interval data, interval scale. So here the gap between the marks, the distance between the marks attributes, it have some meaning. Like 95 is better than 94, but how much is the gap? It's 1. And 80 is actually inferior to 94, and here the gap is 14 marks. So this is actually interval scale. There is an interval. Temperature or for a distance from 0 to 40 is same as distance from 70 to 80. That is temperature in Celsius and Fahrenheit. And note that ratios don't make any sense. 80 degree is not twice as hot as 40 degree, although the attributes values are. Okay. And ratio measurement has an absolute zero that is meaningful. Now what is absolute zero? Can construct a meaningful ratio, a fraction. Okay. For example, number of clients in past 6 months. So it can be like in past 6 months we have an n number of clients. That is actually a ratio measurement. It is meaningful to say that we had twice as many clients in this period as we did in the previous 6 months. Like number of clients in this particular semester, a number of students in this particular semester compared to the number of students in the previous semester. So we are using a ratio. Okay, so this can be compared. The previous semester students and this semester student. Number of students I taught in previous semester and versus the number of students I taught in the current semester. So here two numbers are there and we are using that. We are comparing them. So this is actually a ratio measurement. Okay. The examples are education, number of schooling years. I have 15 years of schooling. Someone might be have 14 number of years of schooling or 18 number of years of schooling. So that can be compared. Monthly net household income, age, number of family members. So suppose someone have 5 number of family members, someone have hello. Someone have 10 number of family members. So this number of family members, this is actually there is no limit that it can go up to a certain extent. Someone might have only 2 number of family members, and someone might be having 108 or 110 number of people in one family. So this is actually about the ratio scale. So when actually we have to, now we have discussed about all the 4 different types of scales. So and when we have to compare the levels in the hierarchy of levels. So at the, as I told you that the nominal scaling, this is the scale that is in the lowest in the hierarchy. This is not a very good measure, but simply it is something we have to assign, then it's better than nothing. That simply, like as I told you, this is just a classification or the nomenclature or identification symbol given to someone. So this is actually a nominal scale. This is the list in the hierarchy. Then it's the ordinal scale. Here the attributes can be ordered, and this is just better than the nominal scale, but still not the best. And the third one is the interval scale. Distance is meaningful, but this is also just third in the hierarchy. And the fourth is the ratio scale, which is the best form of scale we should have. So a ratio scale is considered as the best form of scaling so far as the hierarchy of levels is concerned. Okay. Now, primary scales of measurement. Suppose number of numbers assigned to runners. So this is a runner. So someone have got 7, 8, and 3. So this 7 is just a number given to this runner. Suppose someone is running a race and the jersey number is 7. This person's jersey number is 8. This person's jersey number is 3. So this jersey number, this number assigned to runner, this is a nominal scale. But when they have completed their race, this person is in the first place, this person is in the second place, and this person is in the third place. So we are actually ordering it. So this rank is actually in the ordinal scale. So the jersey number or the name given to the person, okay, name or some number is given to the person, this is the nominal scaling. But when actually they have completed their run and they have scored respective positions, first, second, and third. Now first, second, and third, this is a ordinal scaling. Now performance rating on 0 to 1. Okay, if you have to rate how good that person was while running, So we have given in a scale of in a 0 to 10 scale, this person is given a performance scale rating of 9.6. Suppose we have done a survey like whose performance was better, though he has scored first position, but still we may have looking at the past trend and past statistics, we can have an assessment and we can ask 10 number of people that do you think whose performance is better, how do you rate the performance of this person in a scale of 0 to 10? And suppose the average rating that comes is 9.6. This person has got 9.1 and 8.2. So this 9.8, 9.6 and 9.1 and 8.2, this is actually an interval scale. And time to finish in seconds, this person have taken 13 seconds, 14 seconds and 15 seconds. This is actually in a ratio scale. So see, in the same example, the running, we have converted this, we have used all the 4 scales. So the first is the nominal scaling, then second we have used this ordinal level, then the performance can be converted in an interval scale, and the time to finish is in a ratio scale. Similarly, suppose you have the marks of students of a particular class. So their roll number will be, roll number or the name will be the nominal scale. Then we have conducted the test, and the person, the student who have got the first position, second position and third position, we can just order them, order their positions, and that will become an ordinal scale. Then we can have a feedback of the teachers about those students. Like suppose some student have got first position, but overall his performance is not so satisfactory as per the teachers. We have also seen in the class that suppose some student have got first position, but that student is not likely to be the first, or that is not liked by many of the teachers, and his past performance was not that good. So accordingly we can have a performance rating. Okay, and that's why we have like this, and this will be in an interval scale, and how much marks he has got. Okay, remember this first place is just number 1, but how much marks he has got? 95, 99, 99.9. So this 95 is actually in a ratio scale. Okay, suppose another example, illustration of primary scales of measurement. Suppose we are actually doing a survey on the bank, the services of different banks, and how satisfied we are bank and the performance of the bank. So these are the number, the banks: ABN AMRO, Banco, Bank Brussels, Bank of Ireland, Budapest Bank, Citibank, and Credit or the Dutch Bank, and these are different banks are there. And the preference ranking is given, like this bank is in the first preference, this bank is in the third preference, this is the second preference, and accordingly. Then preference rating between 0 to 7 and 11 to 17, this is also given, and the likelihood of opening an account, this is also given. So this is just the name of the bank is actually in the nominal scale, and this preference ranking is ordinal scale, that the first, second and third. This is okay. Then this preference ranking is an interval scale, and the ratio scale is the percentage likelihood of that opening of an account. So here we have seen that normally with any scale we are using numbers. Here in the nominal scale we have used numbers. In ordinal scale also we have converted their performance into number 1, 2 and 3. Then interval also these numbers have been used. In ratio also we have been using number. So why actually it is numbers? Numbers are usually assigned for 2 reasons. One, first, numbers permit statistical analysis for the resulting data. Okay. So if we have used numbers, then the further statistical analysis is possible using those numbers. Okay. Simply we cannot say that that person is very good person, but with that information we cannot go for any further statistical analysis. That particular student is a very honest student, very intelligent student. So this is a very significant information, but very intelligent, and with this we cannot go for any statistical analysis, further statistical analysis. We cannot draw an inference. But suppose their intelligence is given a score, maybe based on the IQ score or based on their the performance in the IQ score, we can give them an order also, first, second and third. Now this when their intelligence have been quantified, now this quantification can be used for further statistical analysis. Second, numbers facilitate the communication of measurement of rules and result. Okay. what will be the measurement rules and what will be the result. That communication is easier when actually the numbers are assigned to a particular attribute. Okay. Now, primary scales of measurement, we shall be discussing about each one of them, like nominal, all this nominal, ordinal, ratio and interval, and we shall be discussing the different attributes. Like first one is the nominal, and what is their basic characteristics? In case of nominal, they are numbers, identify and classify object. The numbers simply identify and classify object. That is their basic characteristics. I'm once again repeating, like roll number. This roll number is just to identify that student or classify that student, like roll number 1 to 50 in section A, roll number 51 to 100 will be in section B. So that nominal is just a number given to identify and classify object. Some examples: social security number, like your Aadhaar number, numbering of football players. So your Aadhaar number, your PAN card number, your bank account number, these are some of the examples of your nominal scale. Examples from marketing, like the brand number or store type. What store type is this? Whether this is a departmental store, or this is a supermarket, or this is a retail store. This is just an example from the marketing. And what kind of permissible statistics can be used? So far as the descriptive statistics are concerned, we can use just percentage and mode. Okay. And inferential statistics, we can use chi-square or binomial test. So chi-square and binomial test, these are some of the inferential statistics can be used with nominal data. Okay. So you can once again recall your learning that with chi-square test, whenever you are using this chi-square test, so the scale can be nominal also. Whenever you are using this binomial test, okay, so the scale can be nominal also. The data can be nominal data as well. Okay, and with the nominal data, normally we go for the percentage and the mode. Okay, like most of the surveys conducted by the news channels, that how many people they fall into this particular group, like how many people will be voting a particular party. So like I will be voting a particular party. This is just an identification. So 30% are in favor, 40% are against, and 20% can't say. That is just a number, and this is a percentage. So in percentage and mode, this is a descriptive statistics can be used for nominal data. Next is ordinal data. So what is the basic characteristics of ordinal data? Here the number indicates the relative position of object, but not the magnitude of difference between them. Remember, number indicates the relative position of object. Like number 1 is first position, but not the magnitude of difference between them. Like number 1 is 95, number 2 is 94, and number 3 is 80. So here the number will be 1, 2 and 3 only. But the magnitude of difference between number 1 and 2 is 1, whereas between 2 and 3 is of 14 or 15. Okay. So here the magnitude of difference is not actually being disclosed by the ordinal scale, but only the relative position. Like number 1 means he has got the first position or the highest marks or the highest value is been assigned to that particular attribute. This is just the relative position. Some examples: quality rankings, ranking of teams in a tournament. Okay, like the team who has got first, second and third. So that is just quality ranking. Like Team India, at one point of time it was the best cricket team in the world. Now also it is the best cricket team in the world. So like ICC used to give some assign some points for the performance of all the cricketing teams in the world. So suppose Team India have got 130 points, and the next team is suppose the New Zealand, and it has got 115 points, and the third team have got 112 points. So between 1 and 2 there is a gap of 15 points, but between 2 and 3 there is a gap of only 2 points. But when actually it comes to the ordinal scaling, the teams will be first, second and third. Okay, whereas actually the team 2 and 3 are actually very close competitors, and it can change anytime, but this information is not reflected by the ordinal scaling. Some examples from the market: preference ranking, market position, social class. These are actually some of the examples in ordinal scaling. Like preference rankings, there are certain surveys like just you are asked to give your preference for a particular product. Okay, like 10 products are there and you are just giving your preference, like out of 10 which one will be the first, second, third, fourth, fifth, sixth and 10. You are giving that ranking only. So that is actually in ordinal scale. Market position, which company is having the best highest market share, which company is having the second highest market share, so the 1, 2 and 3. Like Intel Inside, so Intel is having the number one market position so far as this computer chips are concerned, and the other company, suppose ABD, is having the second position, so 1, 2 and 3 market position. Social class, okay, that the upper class, middle class and the lower class, that is social class, social stratification, that is also in an ordinal scale. That is the class which is having the highest number or highest amount of money, wealth, will be the upper class, next to that will the middle class, next to that will be the lower class. So that classification is also that ordinal scaling. So what kind of statistics can be used here? Here the percentile and median are the descriptive statistics, and rank order correlation, Friedman, ANOVA. Okay, ANOVA, that is analysis of variance, and rank order correlation, these are some of the inferential statistics which can be used for ordinal data. Now come to this interval. What is the basic characteristics of interval scale? Difference between the object. Here in ordinal, the difference between the objects are not important, but here in interval, differences between the object is very important. That is the basic difference between ordinal and interval. Okay, suppose the marks of a student 95, 94 and 80. So here 1, 2 and 3, that is when actually we are classifying the students on 1, 2 and 3, that is ordinal data, but 94, 95 and 80, that is actually an interval score. Okay. Temperature is an example of interval scale. Attitude, opinion, index, like Bombay Stock Exchange, it is today at 61,000 level, yesterday it was 59,000, before that is 58, at some point of time it was at 62,000. So these are this index, this is an example of interval scale. Range, mean, standard deviation, these are the descriptive statistics which can be used for this interval scale. And product moment, this is an inferential statistic can be used. 0 point is fixed, ratio of scale values can be compared. Length and weight are the examples. Age, sales, income, cost is given. Geometric mean, harmonic mean are the descriptive statistics. Coefficient of variation is the inferential statistics. Now come to this, having understood all these scaling scales, nominal, ordinal, interval and ratio. Now when we have to frame our scale, okay, so this the further classification is this is comparative scales and non-comparative scales. Just a minute, I'm just having some water. Now, using the knowledge of this nominal, ordinal, interval and ratio, now we have to frame scale. And the scales can be comparative scales and non-comparative scales. In comparative scales, it can paired comparison, rank order, constant sum, Q sort and other procedures, continuous rating scales or itemized rating scales, Likert, semantic and staple. These are the different scaling techniques. We shall be discussing about a few of them today. So there are two types of scaling technique. One is the comparative scales. It involves the direct comparison of stimulus object. Comparative scale data must be interpreted in relative terms and have only ordinal or rank order properties. Okay. So when actually the name itself is indicating that there has to be two objects and we are just comparing. Compare between A and B, which one is better. Okay, just like a Swayamvar, there are so many people who assemble to marry to the princess, and the princess can compare between all of them. So that is comparative scale. And in non-comparative scales, each object is scaled independently of the others in the stimulus set. The resulting data are generally assumed to be interval or ratio scaled. Okay, so each object can be independently scaled. For example, uh, if suppose we are giving our assessment, one student have got 100, it does not mean that the second student will not be getting 100 out of 100. So second student will be scaled independently of the previous student. So that is non-comparative scale. But if you are going for a relative grading, as it is done in case of many competitive examination, that is comparative, that we have to choose only the first 2% or first 10%. That is actually we are doing a comparison knowingly or unknowingly. So the first one is the paired comparison scaling. So the paired comparison data can be analyzed in several ways. The researcher can calculate the percentage of the respondent who prefer one stimulus to another. Okay. The researcher can calculate the percentage of respondent who prefer one stimulus to another. Like, okay, we shall be coming to that example very soon. Under the assumption of transitivity, it is possible to convert paired comparison data to the range order, and it also possible to drive an interval scale from paired comparison data using the Thurston procedure. Okay. Now this is obtaining sample preferences using paired comparison. Now what is the instruction? We are going to present you with 10 pairs of shampoo brands. 1, 2, 3, 4, 5, 6, 7. Okay. 1, 2, 3, 4, 5, 6. No, 5 only. Okay. For each pair, please indicate which one of the two brands of shampoo you would prefer for personal use. Actually, this is not 10. We presented 10 pairs. Okay, 5 this way and 5 this way. So, Jirmek, Finesse, Vidal Session, Head and Shoulder, and Pert. This is on this way and this is on this way. Here, 0 means this Finesse and Jirmek, this combination is rejected. This 0 is rejected. Head and Shoulder, this Jirmek and Head and Shoulder, this is accepted. 1, this others are rejected. This 1 means Head and Shoulder and Finesse is also accepted. Vidal Sasson is and Head and Shoulder is accepted. Vidal Sasson and Finesse is also accepted. So if you have to just see the number of times 1, 2 and 3, this is 2, 4 and 1, and this is where actually we are just doing a paired comparison. Comparison is always in a pair. Okay, another way of paired comparison is scaling between, just choose between A and B, which one is better. So the most common method of testing is paired comparison. The consumer is asked to sample 2 different products and select the one with the most appealing taste. The test is done in private and a minimum of 100 responses is considered an adequate sample. This is actually an American example, so we should not go with that. A blind test for a soft drink where imaginary self-perception and brand repetition are very important factor in the consumer's purchasing decision may not be good indicator of performance in the marketplace. So paired comparison test between A and B, we are just doing this. Rank order scaling, respondents are presented with several objects simultaneously and asked to order or rank them according to some criteria. It is possible that respondents may dislike the brand ranked 1 in an absolute sense, but though it is given number 1, but the respondent may not be liking 1. But the thing is that we have been given only those 2 or 3 choices where we have to make that ranking. Just like our election, you might be hating or you might be disliking all the 4 or 5 candidates which are actually contesting in your area, but you may not be liking anyone, but when you have to give your vote, so you will be giving to someone to whom you might be giving number 1 position to someone, though you may not be liking him. Okay, if you just see that the number of the candidate who has won any election, he or she has got say 33% of the votes. Okay, and the candidate who is coming second to that, he or she has got say 30% or 32% of the votes. So the person who has won any election he or she has got only 33% of the votes, it means that 67% of the people in that locality did not or do not like that person. Okay, this is just rank order scaling, that we are giving the vote to a particular person, but still we may not be liking that person. Furthermore, rank order scaling also results in ordinal data. Okay, that 1, 2 and 3 we are doing that order, like the candidate in an election who will be getting the maximum number of votes will be the first, second, third and fourth. So actually it is converted into an ordinal data, and only n-1 scaling decisions needs to be made in rank order scaling. Like preference for toothpaste brands using rank order scaling. So two brands would receive the same rank, it is possible. Okay, like there are suppose 10 toothpaste and you have to just give a rank order, like which toothpaste will be number 1, which toothpaste will be number 2, which toothpaste will be number 10. Okay, so you have given number 1 to a particular toothpaste. It does not mean that you are using that toothpaste or you are liking that toothpaste. It may so happen that the toothpaste that you like may not be in that list, but still, since you have been given a task to rank that toothpaste, you have given a certain ranking to the different toothpaste. Constant sum scaling, a number is given, like you have given 100 points, and out of this 100, how much points you want to give to the different attributes, that is called constant sum scaling. Respondents allocate a constant sum of units such as 100 points to attributes of a product to reflect their importance. If an attribute is important, the respondent assigns it 0 points, unimportant it was 0 points, and it is very important, more points will be assigned to that attributes, and the sum of all the points is 100. For example, importance of bathing soap attributes using a constant sum scale. Now for a soap there are certain attributes like mildness. How important is the mildness? How important is the leather? How important is the shrinkage? How important is the price? How important is the fragrance? How important is the packaging, moisturizing and cleaning powder? Okay, so like you have been given this attribute to the 3 segments. So this segment has given that 8 point is important for mildness, 2 is for the leather, price is 53% as per this segment. Okay, cleaning ability, cleaning powder is 13 out of 100. So the total is 100. This is also one scaling. Okay. Then segment 2, this segment has given cleaning powder as the most important element of but the price is only 17%. Okay, fragrance is not at all important for this particular segment. Okay, for segment 3, 19, this fragrance is the most important, leather is 17%, whereas leather is 2 and 4 for these 2 segments. So ultimately we have average response of the 3 segments we have calculated, and now we have this data. And which scale is this? Interval scale. Okay, so now using this data we can do a lot of statistical analysis. How important is, similarly you can have, as per your requirement, someone is doing the study in political science. So in political science you can do a study like what are the attributes of a good leader, a good political candidate, and you can just identify all those attributes, and you can just ask your respondent to constant sum scaling, like out of 100 how much points you will be giving for the different attributes. Suppose someone is doing a study in marketing, so you can identify the attributes of a product, different attributes, and you can just go for a constant sum scale, out of 100 or 200 how much points you want to give to this particular these attributes, and you can just identify them. Now the last one is the Likert scale, that is the non-comparative scale, Likert scale. Now what is Likert scale? Likert, the most popular scale, and many of our students, especially in the management and commerce and economics, and even in other social science department disciplines, people normally go for this Likert scaling. And what exactly is the Likert scaling? Is a 5 or 7 point scale which is used to allow the individual to express how much they agree or disagree with a particular statement. Now this Likert scale, when actually it comes to this measurement of attitude, so this Likert scaling is very important. And for example, if you want to measure a particular thing, say that latent that the risk perception of a student, risk perception of an investor with respect to equity share. Like investors are investing in shares. Now, what is their risk perception? And actually, if you want to find out the risk perception of the people, investor with respect to equity shares, you have to go for a Likert scaling, and you cannot simply ask that person that, sir, do you think that equity shares are risky? And definitely he or she will be saying that risky, but everybody knows that there is a risk involved in that equity share investment. Or suppose you are doing some study on like the risk perception of the statement of the students with respect to their digital payment, that they are making payment with phone pay or Paytm or Google Pay. Now, to what extent they feel that this is risky? And if you just ask them, it will not give you. But if you ask different questions, and based on the answers given by those students or respondent, you can identify, you can arrive at a single figure that what exactly is the risk perception of the people with respect to the equity share or digital payment. Then you can calculate that, and it can be done on a Likert scale. I'm giving you another example, like uh, how good a student is. So simply, if you just ask how good a student is, so there are different parameters of goodness. Someone might be thinking that a student who is scoring very good marks in exam, that is a good student. But someone might be thinking that that person who is scoring very good marks in exam, but he is very naughty in the class, so that may not be. So scoring marks is one attribute, his attention in the class or her attention in the class is another attribute, his attendance in the class is the third attribute, his timely punctuality in the class is the fourth attribute. So attendance, performance in the exam, punctuality, these are the different attributes we have identified for a student, and we have done a survey that whether Mr. X or Miss Y is a good student or not. And on a scale of 1 to 5 or 1 to 7, we have like punctuality, Mr. X, punctuality, 1 to 7. Okay, here someone have given 6, someone have given 5, someone have given 7. Attendance, punctuality and attendance are different. Like punctual attendance is simply he or she is present in the class but not complying with the rules, like submitting the assignment or making presentations. He or she is not doing it on a timely basis. So though he is present but he is not punctual. So on punctuality, we are asking the respondents about their rating on a point of 1 to 5 or 1 to 7. On attendance, we are asking to rate that student on a scale of 1 to 5. On performance in the exam, we are asking them to rate on 1 to 5. Then attentiveness in the class, we are asking them to rate on a 1 to 5. And now taking together all the responses, all the 4 responses of different individuals, we are trying to arrive at a single figure, and we will be uh, giving our verdict that whether someone is good student or not. So that is actually Likert scale. Okay, so Likert scale typically provides 5 possible answers to a statement or questions that allows respondents to indicate their positive to negative strength of agreement or strength of feeling regarding the question or statement. Now how? Like agreement may be like, suppose someone may, the statement may be like, I do not understand the selling price or the buying or selling price fixes and mechanism in a stock market, and that's why I do not invest. That is a statement. And I might be simply agree or strongly agree or undecided, disagree or strongly disagree with this. Someone else might be having a different response. Someone third person might be having a third kind of response. And this is how actually we can just put a like we can just go on writing those statements. Another statement that say for with respect to the digital payment, that I do not see the physical evidence of that transaction, and that's why I think that I hesitate to make payment digitally. So with this statement, I may be agreeing or I may be disagreeing, or strongly agree to strongly disagree. I might be giving some of my responses. Third statement, for example, uh, I have seen people losing money while making digital payment. I have seen people victim of fraud while making digital payment. These are the two statements. And now with this we have to do, we either will be agreeing or will be disagreeing. Strongly agree to strongly disagree. This is and this is how we can have a list of all those statements, and with this all those statements we can ask the respondents to rate their opinion on a scale of strongly agree to strongly disagree, this one, and we can just then go for some statistical analysis further. Similarly, here it is on the basis of agreement, it may be on the basis of frequency, like what is the frequency of using this digital payment? Do you always use, often use, sometimes, rarely, and never? Okay, so the same, this that is on a frequency. So this is on for frequency. Then importance, very important to not at all important. This can be another scaling, another, some statements may be given, and the scaling may be very important to not at all important. But one precaution is that if we are using this important to not important, very important to not at all, then in almost all the statements we have to use the same scale. And if you are using this always, often, sometimes, rarely, then all the scales has to be on the same scaling. Okay, it is not a sign of good scale that one scale is on strongly agree to strongly disagree, and the second sentence is in terms of frequency, and the third sentence is in terms of importance. If it is in terms of agreement, all the 5, 10, 20, 50 number of statements should be on the same scale. That is actually a characteristics of a good Likert scale. And there is a quality: excellent, good, fair, poor, and very poor. Likelihood: definitely, probably, possibly, probably not, definitely not. So these are different parameters of seeking response from the respondents in a Likert scale. So here it is on a 5 point, it can be on a 7 point also. So definitely it will be in an odd number. 7 point or 5, more longer is the scale, more probability, the more chances are that will be getting adequate response. But why not 3? The Likert scales, either these are 5 point or 7 point, but not 3 point, because 3 point is that people have the tendency of putting the response in the middle. Okay, so that most of the time they will be keeping the response in the middle, and that's why that likelihood or the probability that we'll be getting the correct response will be not there. And that's why some of the scholars are of the opinion that here the Likert scale, the statements are fine, but instead of 5 point we should give them 4 point or 6 point. Why? If we are giving 4 point, then because in 5 point there is a midpoint, but in a 4 point either will be good or poor. There is no middle point. So depending upon the scale, depending upon the research that you are doing, you can develop any scale of your, you can use any point scale, whether it is 4 point, 5 point, 7 point, sometimes 9 point and 11 point scaling is also done. It is also possible. Now when we have framed the scales, the next question is the validity and reliability. The scale, whatever we have constructed using this Likert scale or paired comparison or this binomial scale, these scales we have constructed. Now two things has to be ensured: that the scale has to be reliable and the scale has to be valid. And most of what we have dealt with so far has that to do with the reliability. Now what is reliability? It is the extent to which you will get the same result when you repeat a measure several times. One questionnaire you have developed and you have circulated the questionnaire, and then you have this questionnaire you have circulated, you got some answer, and after some if the same questionnaire is circulated once again, the probability that you will be getting the same answer, same result, if it is there, then it is your questionnaire, your scale is reliable. But reliability does not mean that it will be valid also. Validity is the extent to which you are measuring what you think you are measuring. Okay. Now let me give an example. Let me explain how reliability and validity is different. Right now it is, as per my watch, it is 3:10. 3:10 हुए हैं. Okay. After 1 hour, it will be 4 hours and 10 minutes. 10 past 4. So it means my watch is reliable. After 60 minutes, it is supposed to give me this. It is supposed to show me the time 10 past 4, and it is actually showing me, means my watch is reliable. And what is the actual time? Actual time is the same also. It's 3:10, and after 1 hour it will be 4:10. So my watch is reliable and as well as valid. But suppose there is some problem in my defect in my watch, and because of any reason, right now the times shown by my watch is say 1:30 p.m. and after 60 minutes it is supposed to show me 2:30 p.m. It means my watch is reliable, and purposefully I set the time 1:30, and after 60 minutes it is supposed to show me the time 2:30 only. Means my watch is reliable, the timing shown by my watch, timing given by my watch is reliable, but the timing is not valid because right now it's not 1:30, it is 10 past 3. So my watch is reliable but not valid. So your instrument has to be reliable as well as validity. And how to ensure reliability and how to ensure validity? There are certain tools available. The most commonly used tool to test the reliability of a questionnaire, reliability of a scale, is the Cronbach Alpha. Okay, it is available in SPSS. Just you do some, just go for do some this Google YouTube search, and you will be able to find how this Cronbach Alpha is calculated. And if the value of Cronbach Alpha is more than 0.70, it means that your scale, your questionnaire is reliable. But so far as the validity is concerned, you have to go for testing this instrument, and this instrument at this scale has to be weighted by some experts. Some experts in the field will be telling you that whether the scale which is reliable is also valid. Means actually it is measuring the attributes, it is actually measuring the latent variable, what actually it is intended to be. Suppose you have developed a scale to measure the attitude of investor towards equity share investment, and the scale is actually measuring the attitude of the investors towards equity share investment. Who will tell you? The expert in that field will tell you that this scale is covering all the dimensions of measuring the attitude towards equity share investment. So using frequency of jogging as a measure of exercise is not valid because there are many other forms of exercise. So this is reliable but not valid. So much of the question wording is about validity. Now, there are certain common mistakes in designing questions, or there are certain common mistakes in designing the scales. And what is that scale? First one is the not mutually exclusive. Like, what is your income? 0 to 20,000, and 20,000 to 40,000, 40,000 to 60,000. Now, suppose my income is 20,000. So where should I put this tick? Here or here? Okay. So it is confusing. Though some of the statisticians are of the view that this is actually an example of exclusive class interval. The upper limit is excluded. So if my income is 20,000, I will be putting tick here. But everybody is not a statistician, and everybody is not intelligent like me, that I have been given some learning about this exclusive class interval. So better if you have just 0 to 19,999 and here 20,000 to 39,999, that will be the better classification than this one. Then not exhaustive. If you are just making some scale and the options are not exhaustive, like where do you get most of your medical advices? And the options I have given: my doctor, TV, friends, family members. And do you think that these are the list is exhaustive? Suppose someone have got medical advice, say from online counseling, not TV, some internet. So where that person will be putting the tick mark? that person do not have the place to put tick mark. So that is, the scale should be exhaustive. Okay, so here if you are not sure that what are the options, then we can put a here number 5 like others and specify. Okay, suppose if you think that you have specified all the options, but yet there may be some other options, so here we may put others, and within bracket we may write specify. So now it is actually somehow we are trying to make it exhaustive. Too long and wordy. People don't like to read too long sentences. For example, the next question asked about your own health care. Please do not include care you got when you stayed overnight in a hospital or the times you went for dental care visits. For the purpose of this survey, a personal doctor or nurse is the health provider who knows you best. This can be a general doctor, a specialist doctor, a nurse practitioner, or a physician assistant. When you were enrolled in this program or at any time since, then did you get a new personal doctor or nurse? No. जब तक ये लास्ट वाला पूछो आगे वाला भूल जाते, पुराना भूल जाते, yes or no. So that too long and wordy, this kind of sentences and this kind of questions should be avoided. Double barreled. Double barreled, please rate your satisfaction with the amount and the kind of care you received while you were in the hospital. Now suppose when I was in hospital, so I got good amount of the amount of care that I received is a good amount, like the nurses and doctors, they have given good amount of care to me, but the kind of care I do not know, I am not satisfied. So far as the time devoted to me by a nurse or doctor is concerned, it is, I'm satisfied, but the quality of care I'm not satisfied. So where should I put tick mark? So double barrel question should be avoided. Leading. Most doctors believe that exercise is good for you. Do you strongly agree? Here actually this is leading. Okay, nowadays this most of these apps, and they are asking for your feedback, and most of the time they are already pre-filled with 5 stars, like please rate your experience with this app, and this 5 stars will always will be pre-filled. So most of the time this 5 star will be coming and the people will be just pressing the submit ho gaya, and they will be showing that hamare itna 10 million customers have given 5-star rating, but actually the 5-star rating वो पहले से ही fail होकर के आया था. So अगर आपको, if you are not satisfied, then you have to delete 4 stars, 4 3 2 1 delete करना पड़ेगा आपको, click करके, then you have to submit, press submit. Normally people do not do that. This is actually called leading. Here the respondent is leading towards a particular answer. Most doctors believe that exercise is good for you, and who the idiot will be there in this universe who will be saying that exercise is not good for me? जो दिन को 12 बजे सो के उठता है और सीधे खाने बैठ जाता है, वो भी बोलेगा exercise is good for me, क्योंकि वो बोल दिया उसको. Unreasonable. Unreasonable question. How many times in the past year have you eaten out? Is it possible to remember that past 1 year, past year, how many times I have eaten out? It's not. But if I have to do survey of this kind, if I do like how many times in past 1 week I have eaten out, or normally in 1 week I have eaten out, now it is possible. Like in last 1 week or in 1 week, normally I go for once in a week, and if it is 52 weeks in a year, then multiplied by 52. Okay, आपने पिछले 1 साल में कितनी बार दाढ़ी बनाई? It's not possible. But एक सप्ताह में कितनी बार बनाते हैं? एक बार, multiplied by 52 times, और 15 days में एक बार, so 26 times. It is we can calculate it. So this unreasonable questions should be avoided. Too many categories to choose from, will often choose the first or last. इतना ज्यादा कैटेगरी हमने बना दिया कि याद ही नहीं रहता. Please describe the first page of the website, and so many categories. People normally do not remember, so this should be avoided. Then certain points, like when repeating surveys Be careful of making changes to response categories such that response numbers mean different things in different versions. Some questionnaire authoring package allow you to randomize the order of questions and response categories. Okay, so randomize, just like in CBSE there are 4 different sets, so the questions are randomized so that to avoid the copying by the students. Alternate questions that are phrased positively and those phrased negatively. Sensitive and controversial questions should be phrased so that the respondent feels okay about selecting a negative response. We should avoid sensitive and controversial questions should be phrased in such a way that respondent feels okay, we can part with this information. Like, do you smoke? And if a person is a chain smoker, then also most of the time in India that person will not be accepting the fact that that person is a chain smoker or is a smoker. Especially suppose if you ask this, do this survey on a school kids or a college going kids, then definitely they will be giving an ideal answer. Okay, but if you ask what percentage of your friends or classmates they smoke, so if you're saying that 70%, okay, so in that way we can find out the correct answer. You should typically offer a don't know and not available category. That is also possible, like I don't know or the options not available, none of the above. This should also be there, but ultimately depends on what kind of survey you are doing. Some open-ended questions, it should also be there. Okay, so typically used when you are unsure what the response categories should be, you are not knowing what the response categories, then you should be giving these open-ended questions. Sometimes used to provide text examples to illustrate points, and other specify is often included as the last of a set of response items to cover unanticipated response. So does your child have any special healthcare needs? Yes, no, don't know, refuse. If yes, what is the diagnosis? Okay, so this is one example of open-ended question. What kind of place do you go to most often when you are sick or need advice about your health? Clinic or health center, doctors? So this is actually uh, based on this the first response. We are actually now designing this open-ended questionnaire. We are giving now more here. Like, does your child have any special healthcare needs? Yes, no, no, refuse. And what is that diagnosis? And accordingly, we are just designing it, rephrasing it. So typically, researcher reads through all open-ended responses and decides if new response categories seem to come up, then recodes open-ended responses to the new categories. So may use text analysis software, that is Atlas, and these are some NVO, the text analysis softwares are there. So this is all about some this scaling and scaling techniques. And if you have any question, please feel free to ask.